All right, so today's lesson in geometry and shapes is similar solids. So the theory goes that if all the side lengths have the same ratio, so the length of the small and the length of the big is the same ratio as the width of the small and the width of the big, then that means that these are similar solids, meaning that not only will their sides be the same ratio, but their surface areas and their volumes will have the same ratio. Okay? So in this case, now what we need to find in this problem is we need to find the original ratio of the sides. So we're given the volume on number 13, but now we need to find the ratio of the sides. Okay? So let's say so we know that, here's the example. So if we're looking at volume, we know that 1 cubed over 2 cubed, meaning the original ratio was 1 over 2, would equal 1 over 8. Okay? So the idea is that the ratio of the volumes would be 1 to 8 because of the similar shapes theorem. So we know that the two volumes are this, 27 over 729. And that will equal the ratio of the sides as well. Now, what we do is we're going to reduce this fraction to as small as we can. Okay? Let's see. I think 9 can go into both of those, so 9 goes into 27 3 times. Let's see. For 729 and 9, let's make sure that works. 81. So 3 over 81. And I know 3 can go also into 81. So that would equal 1 over 27. So the ratio between the volumes, so 27 over 20, so small over big, reduced down to 1 over 27. Now, this 1 over 27 is equal to something cubed over something cubed. Okay? So we need to find out 1. So 1 equals x cubed. Again, the way that we get that is we take the cubed root of both sides, and the cubed root of 1 is 1. So the top number is 1, or the small side length is 1. We know that. Okay? And then the cubed root of this, the cubed root of 27 actually equals 3. So that means the side length of this square is 3. So the original ratio that we got is that the small cube has side lengths of 1, and the big cube has side lengths of 3. So the ratio is 1 to 3. From solid 1 to solid 2, the ratio is 1 to 3, or if you want to do backwards, it could be 3 to 1. So that is how you find, given the volume, the original ratio of the solids.